In this video, we'll be once again looking at the compound interest. This one, however, specifically says how long will it take to deposit $2,000 to reach $6,000 if it's deposited into the following accounts. Now, so we'll be giving two different accounts here. And again, logically, we're going to ask which one compounds it faster or which one is better for us to make this investment in. With this first account, you'll notice we have 1.5% interest compounded monthly. Now, just so you know, 1.5% interest is a very uncommon savings account interest. In most savings account, you have less than 1%. Keep in mind that if I have 1%, 1.5% correlates to an R value that is equivalent to 0.015. Okay, so again, the decimal place moves over twice to get me my percentage value. My P value is the amount that, again, I'm investing, and that's going to be $2,000. The A value that I'm always looking for is the amount that I'm getting back, which normally we don't know, but in this case we want it to get to be 6,000. And then we want it compounded monthly, which means I'm looking for an N value of 12. If this is the case, I'm going to go ahead and use again that first formula, not the second one, P times 1 plus R over N to the power of N times T. And notice I'm be given R, there's my rate, I'm be given P and A. Okay, I'm given N, the only thing I'm missing is T, which again, how long will it take? I'm looking for T. Also note that, just to help you guys, T is always going to be in terms of years for these types of problems. So, I must plug all these values in. I'm going to have 6,000 equals to 2,000 times 1 plus my R value is 0.015 divided by my N value is 12 to the power of 12 times T. Now, a few things you can do in this problem. Again, first step is if I'm solving an exponential equation, I need to get the exponential function by itself. So I'll divide both sides by this 2,000. Again, that 2,000 multiplication is simply sitting in front of the exponential. This right here has the power of t on it, so this thing right here is my exponential equation. So when I divide by 2,000, these two things cancel out. I'm left with 3 is equal to 1 plus 0.015 divided by 12 to the power of 12t. Notice that all the numbers in these parentheses are, so all these things in the parentheses is simply just numbers. So knowing that, we could actually go ahead and type this into a calculator without the 12 and without the t to evaluate what that base is really supposed to be. So we'll go ahead and do that here on my calculator. I'm going to have 1 plus, and in parentheses I'm going to very carefully type in 0.015 divided by 12, ending my parentheses. Notice again how it displays on my calculator. This is 1 plus, again, the exact fraction that I'm looking for here. So my decimal value is 1.00125. Also make note that I will not be rounding that value, 1.00125. Also note that it's not 8 or 9 decimals, so that we can be absolutely certain that this is not approximated from the calculator. This is as exact as possible. And we need it to be as exact as possible. Now, there are two other ways to do this problem, remembering how to solve an exponential equation. We may either, from this step, if I have a base to the power of something, take the natural log of both sides, or if I have the base to the power of something equal to another number, I could attempt to get the bases to the same. That's not going to happen. Or, in the last case, which is, again, the more common option, is to simply just change the form of this exponential equation to a logarithmic equation. However, in doing so, I'm going to change it to a base that I don't have in my calculator, so I'm going to go ahead and apply the natural log to both sides. In doing so, that 12t is now inside of a log function. Again, I've applied the log to both sides, to this 3 and to this whole thing. That 12t can now be dropped down in front because it is simply an exponent inside of a log. And now lastly, to get t all by itself, I will simply divide by 12. That'll cancel out that. And the natural log of 1.00125. That'll cancel out that. So this will give me that t is equal to the natural log of 3 over 12, natural log of 1.00125. Now again, make note, is there anything I could do to simplify this? And the answer is no, because if I had a natural log of two things divided, that means I could change the log of two things to the log of one thing inside of a subtraction. But because they're two separate logs divided, I can't do anything with that. So my best guess is, again, to return to the calculator. In this case, I'm going to go ahead and type in the natural log of 3. I'm going to divide that by 12 times the natural log of 1.00125. Now, look very closely at the way I've typed this in. Okay, if you're typing this into your calculator, in some aspects, this will come out as a wrong value. And the reason why is because it's going to treat this as this divided by 12 and then multiplied by this number. It's going to follow the order of operations that follows the order of operations. I'm going to do division and multiplication at the same time, but from left to right. So this division is going to happen first, and then that multiplication is going to happen after. So to fix this, I'm going to have to type in an extra parentheses there and an extra parentheses here. Okay, so be very careful about how you're typing this into your calculator. When I hit enter, this provides me approximately 73. What that tells me is after, and I'm going to go ahead and round this off to 287. What that tells me is after approximately t equals 73, which is supposed to be years, after 73 years, if I have a savings account at 1.5%, it'll take 73 years for $2,000 to get to $6,000. This should be a very, very clear lesson that we are looking for more higher percent interest values in savings accounts, which is why, again, they generally use stocks and bonds, because their interest return rates is much higher than 1%. But this is not going to be very much money, but that's, again, for going from $2,000 to $6,000. For us to triple the amount of money we have, at a 1% interest, 1.5% interest, it'll take us 73 years to do so.